Hi, everybody. So our group did the paper on HapToes, which is a system that uses vibrotactile numeric information delivery via a tactile toe display. So this is a pretty interesting paper that went through sort of the introduction and background to single actuator and multi-actuator designs for conveying numeric information, how you just give numeric rendering, that's the official term, haptic numeric rendering for different kinds of systems, what exactly this system does using toes, and then the results and implications of that study. So jumping right into it, you can. The sort of overall approach to indicating, like using actuators and haptics to convey information has done a lot of research with single actuator systems, which are your typical Fitbit, sort of vibration wearables. Your phone is a single actuator system where you're receiving the information from one point. And the problem with that is there's a really limited number of distinguishable patterns that you can sort of give with a single actuator system. As we saw in some of the demos today, you can have pretty complex vibration patterns, but all of those patterns are pretty limited to just that one place. And they can use a lot of the different sort of design space of frequency, amplitude, and duration of vibration. But what a multi-actuator system and what the toe system here is able to do is incorporate the location, sort of the spatial recognition of where that vibration is coming. And that just really opens up the design space for conveying information with a haptic system. However, the problem with this is that there's not a lot of they're struggling to find sort of the real world feasibility of these systems, because any sort of movement with your feet as you're walking or doing anything is really difficult to sort of counteract and dampen out so that you can still feel the haptic feedback while you're walking or doing anything. That being said, this has been sort of explored for more sedentary tasks. And it can, they're interested into whether this can decrease the cognitive load on users who are receiving notifications and information from a lot of different senses, including like their sight and their hearing and their fingers, which are also usually doing something. So it's a question of whether using your toes as more information input is really overwhelming or if it can actually be useful. So something that they have been exploring as they are trying to give haptic feedback to convey information, particularly numeric information, is that having to associate a sort of abstract pattern to a number is not that difficult of a task for humans to do, but they sometimes do have difficulty recognizing that they're receiving this input. And particularly with single actuator systems, they found that humans actually need a little bit of a wake up, being like, hey, we're going to give you a signal, be paying attention right now. And so that pre-signal vibration that single actuator systems and multi-actuator systems are actually really important, and those were used in this study as well. They first will vibrate the actuator that they're going to use for the multi-actuator or for the single actuator, and then they'll give the haptic pattern that will sort of convey whatever it is that the data that they're trying to convey. And this can also sort of help prevent the sensory overload of being able to focus someone's attention on exactly what they're doing. How exactly the two different systems are being used to convey a number. So the first one that this study really compared itself with is the ActiVibe Final, the AVF, and that was a single actuator system that delivered one vibration pulse to the wrist, and they would have one really long pre-signal vibration and then a varying number of short bursts to convey a single number. Whereas the toe system is a lot more complex, so each toe is connected to its own haptic vibration system, and individual toes could be vibrated for longer periods of time and also have sort of the pre-signal as well. But they found that your middle toes are kind of hard to distinguish, and people would also often get confused and think that their middle toe was vibrated when actually it was their ring toe, or their fourth toe. And so they found that it was easier for people to distinguish between those by having sort of a hop-on feature. So for example, with the number 2, they would lightly and short, and like for a short time, vibrate the pinky toe, and then for a longer and more higher amplitude, vibrate the ring toe, and people were able to really feel that difference. So that's sort of the 2 methods that this paper was talking about for conveying a single number and also a group of 3 numbers. And that was sort of the benchmark for what they were looking at.
Cool, so now we can move on to the user study. Participants had a toe rendering device with 10 vibrotactile actuators strapped to their feet. And on top of that, they used the tablet to enter responses that they perceived in the study. They were also told not to look at their feet and given headphones to drown out the audible sound of vibration. There were 2 tasks associated with the study. The first was recording the communicated number. So participants received either 1 or 3 values and were asked to give their best guess interpreting the 1 to 10 value. And there was also a question mark option, which was actually default. So this will come in handy later. Trials continued for 8 seconds. So taking longer than 8 seconds without answering automatically submitted a question mark if they were completely unsure. The second task was the simultaneous audio distraction. Participants would hear color names from a text-to-speech and told that the primary task was to report the color name blue when it was spoken onto the tablet UI. So as shown on the right, it's a little setup of the actuators and the vibrotactile actuators and device with the tablet. And then on the far right is what the UI would look like with 3 columns for the 3 value tests, and then a button that says blue if you hear the word blue. So for both the 1 input and 3 input studies, the trials measured missed rate and error rate, which are actually different. And this is important to note because the missed rate is the rate that the participant put a question mark or did not answer for 8 seconds. And the error rate is the missed rate plus the rate at which they answered differently from the input. On top of that, they measured the absolute difference between input and answer, the response time, the render and response time, and the overall performance on the distractor task. So all of these results were compared with the AVF rendering, which was discussed earlier.
So moving into the results here, so on the left-hand side, we have figure 4, which displays the missed rate and the error rate. So you can see from the far left of that figure, there's very little difference between the AVF and the toe methods working with the 1 single value test. And moving into the 3 value test, the missed rate was still about the same and statistically insignificant from each other. However, the error rate was actually significantly larger in the AVF method, which is what this paper was comparing themselves to. So they improved upon the effort. On the right figure, we have the DIA graphs, which essentially show the magnitude of the errors made. And in all these cases, you can see that EVF has a substantially larger magnitude of errors reported compared to the toe. And the reason for this is that in the AVF method, you're keeping track and counting how many vibrations you're feeling in the wrist. Whereas in the toe method, you just feel different parts of your foot vibrating. So people who lose count will often report higher values. And interestingly enough, because of the fact that the numbers are split up between the feet, 1 through 5 on one and 6 through 10 on the other, it's actually very hard to have an error larger than 5, because otherwise you'd be feeling vibrations in one feet and reporting feeling vibrations in the other foot, which is much less unlikely. Then we have a graph showing the render plus response time, which essentially says how long does it take for the machine to convey the information and how long does it take the person to respond to it. In all these cases, there's insignificant differences between the AVF and toe methods. However, it does take a little bit longer for the AVF to render their response or render their information. We also have the distractor task data. During the one value test, there is relatively no difference between the two mechanisms. However, in the 3-value test, the toe method has a 10% higher accuracy rate, which suggests that the toe method actually takes less cognitive load on the user. And finally, we have a user questionnaire that just sort of showed how people preferred everything. Overall preference, 15 out of 24 people chose the toe method. But for accuracy and effort, 19 out of 24 participants preferred the toe method, which is significant or statistically significant. So in the end, the toe method relies on spatial mapping rather than temporal mapping. This can serve to reduce the magnitude of the error when it's made, and also reduces the time to convey the information. Additionally, toe has a lower cognitive load than the ABA method. However, the study authors were keen to point out that these two methods are not necessarily great to compare directly to each other. Each has their own strengths and is useful in different situations. But again, as Anna went over in the beginning, this test was designed specifically for sedentary tasks, and for the future, there needs to be some work around haptics in perhaps shoes that can work as the person's walking around.
Awesome.